This podcast continues to cover data collection methods in social science research. At this point, we're going to consider something called mixed methods. And as the name implies, we use multiple data collection methods in order to collect the data for our research project. Now, why would we do this? Because each of the methods that we've considered so far has limitations, we can assess in a more critical fashion if the results hold up using different data collection procedures. For instance, we could combine survey research with experiments and see if our conclusions hold up with hypothesis testing using slightly different data collection methods. That's a real pro. A downside or a con would be that, well, two cons. It would be more time consuming to do multiple methods since we're doing two different methods as opposed to just one. And it's also more expensive to engage in mixed methods. Now we're going to move on to the who, what, and when aspect of research design. Who or what concerns the units that we will be analyzing. When concerns the time points in which we make these observations. So we can turn all of this into a unit of analysis. The unit is indeed the entity the data comes from. Who are they? Or what are they? And when are they measured? So we'll use three examples. We'll use first of all the interview example. And in the interview example we're going to consider here, we're going to ask a small number of Americans multiple in-depth questions on December 15th, 2020. Thus, the unit of analysis is Americans on December 15th, 2020. Let's consider another design, the natural experiment, where we're studying yearly public education spending in Canada from 2010 until 2020. So our unit of analysis would be Canada in the years 2010 to 2020. Each year. Another natural experiment example would be each U.S. state's response to COVID-19 each month between March 2020 and December 2020. So the unit of analysis would be each U.S. state, the 50 states, between March 2020 and December 2020. So each month, March, April, May, June, July, August, September, October, November, and December. Now, as far as unit of analysis goes, there are three different types of study based upon our understanding of what the units are. Cross-sectional, time series, and cross-sectional combined with time series. So let me explain. If we look at the flow chart, we flow from left to right, and we ask ourselves first, how many unique units do we have? If we have just one unit, and yet many observations over time based on that one unit, then we have what is called a time series design. For instance, if we had annual GDP per capita measures for the United States, we're just measuring in the United States, so that would be the unit. But if we are looking at it over time, over a number of years, then we have a time series design. Now, if we go down from the how many unique units to many, then we could move from many observations over time to one observation each. Now, one observation each implies one single time point, which is called a cross-sectional design. Now, we could have many observations over several time periods, like years. So that would be called a cross-sectional and time series design. Cross-sectional designs have multiple unique units, one observation each. So multiple individuals, multiple states, multiple countries, those would be cross-sectional. If we're thinking about an interview example, it would be a small number of participants that represent diverse characteristics. We could ask multiple in-depth questions, but only at one particular point in time. We wouldn't conduct this survey over several years, but just at one time point. Another survey example would be, well, we could conduct a survey of 100 people at one point in time. Participants represent diverse characteristics. We could ask multiple and generic questions in a survey example as opposed to multiple in-depth questions in the interview. Then with a natural experiment example, we could examine the impact that ideology has on each U.S. state's response to COVID-19 on August 15, 2020. What this means is that on August 15, 2020, we could just simply look at each state and see what its response to COVID-19 is, and take that snapshot, and then figure out if the ideology of the state has something to do with the policy that they adopted on COVID-19. A time series design is quite different. We have one unique unit, but multiple observations over time. So the equivalent in the interview would be to interview one person over multiple time periods, perhaps days, weeks, months, or even years. We would ask multiple in-depth questions. So that's an interview example using a time series, only we would repeat those questions so that we have repeated observations. With the survey example, again, we could conduct a survey of just one person and ask multiple generic questions, and again, repeat this survey several times to generate data points. And the natural experiment side of things, we could examine the impact that the economy had on Idaho's response to COVID-19 each month between March 2020 and December 2020. And as you can see, that would add up to 10 observations, which is not bad. What we would do is we would try to figure out what the impact the economy has on Idaho's response each month. And that would be a time series response. So we'd have 10 different responses based on the month. Okay, so if we want to combine cross-sectional and time series, then we'd have multiple unique units and multiple units over time. So we have multiple individuals, multiple nation states, multiple U.S. states. We have them combined. In the interview example, we'd still have a small number of participants who would represent diverse characteristics. We'd ask multiple in-depth questions over time, and then repeat these interviews over certain time points. So for the survey example, we conduct a survey of 100 people, let's say, also representing diverse characteristics. We'd ask multiple generic questions, but we'd repeat this on a rolling basis, month after month after month, to see if there's a difference in their viewpoints. Now, the natural experiment example would have us looking at the ideology, the impact that ideology has on each U.S. state's response to COVID-19 each month between March 2020 and December 2020. So we would have 500 observations, 50 states times 10 observations for each state is equal to 500. So we have 500 data points. That's a lot of data points. One of the virtues of the cross-sectional time series design is that you do generate a lot more cases. So you have a decision to make. Should you use the cross-sectional design, the time series design, or combine the two and try to get the best of both worlds? So the cross-sectional study, let's consider when it's useful, another example, and some pros for the cross-sectional and cons. So for cross-sectional design, if we're interested in examining many units at one time point, the cross-sectional design is perfect. So imagine studying all government responses to COVID-19 on the day of their first confirmed case. We can do that. We're going to have stronger external validity because these findings can apply to multiple cases. However, these findings are also bound by time. They may not be applicable to other time periods. Perhaps our responses to COVID-19 have changed over time. There could also be weak internal validity if we have a large number of cases, because we lack detailed information about those large number of cases. It's hard for us to give a detailed account of how the independent variable affects the dependent variable in every single case. Well, in time series, let's consider its utility, an example, pros and cons. So, when is a time series useful? If you're only interested in measurement of one unit. when you want to observe the effect of the independent variable on the dependent variable over time. And there's a causality question there as well. Right? So for something to cause something else to happen, it has to have happened prior to that object that's being manipulated. So for instance, we could study yearly US military spending from 1900 until 2020 and try to determine what might explain variation in US military spending. So there's a stronger internal validity for this particular design. There's only one case, so you can observe how changes in the IV lead to changes in the DV in detail. However, a drawback is that there's weaker external validity. The findings only apply to the subject analyzed, and also there are other potentially relevant independent variables that may also cause change over time, changes in the dependent variable. What about the cross-sectional and time series design combined? Well, if we're interested in studying multiple units, but we want to see what happens to those units over time, then we definitely want to try this design. So the example here would be studying all military spending in all countries around the world from 1900 until 2020. So that has very strong external validity. We can apply those findings to multiple cases over time, but it's likely that we have weak internal validity. Large detailed information about cases is just not existent. So it's hard to give a detailed account of how the independent variable impacts the dependent variable in every single case. So, summary of the research design steps. So for number of observations, quantitative is a large N design, qualitative is a small n design. Qualitative data is often secondary data. Quantitative data is often primary data. One prominent method of collection for quantitative designs is through surveys. Qualitative design use all kinds of experiments, case studies, interviews and focus groups, participant observation, and mixed methods. All of those gravitate towards smaller n. If we're interested in studying the behavior of individuals, the large N design makes a lot of sense. Small n design, we can study groups, we can study organizations that are often smaller in number than individuals. The quantitative design allows us to look at one observation over time. The small n design is more flexible. It allows us to examine larger number of observations over time. And that is the end of this podcast.